Okay. So looking at the dividing piece, if we have, number 1, x to the third divided by x squared. So we're going to list out our fraction. How many x's do I list in the top? 3 x's, all attached through multiplication. In the denominator, how many do I get to list? 2 of them. Does anybody know what happens if you have something that's the same on top and bottom of a fraction? They cancel out. So just like if, on a little side note, so on a side note, if you had 6 divided by 2, what is 6 divided by 2? 3. The reason why, 6 can be rewritten as 3 times 2, right? So this fraction would be exactly the same, 6 over 2. You could cancel out both of your 2's, which is how you get your answer of 3. So for this problem, you cancel out what's the same on top and bottom. So there's one set of x's that cancel, a second set, and yes, you'd be left with x. So your simplified form for problem number 1 on the other side of your paper would just be x. So then let's look at problem number 4. Problem number 4, we have a bigger fraction. I'm going to write it out. On the top, how many 5's do I get to list? How many 5's? I only have 1 5, but I do have 5 x's, so I'm going to list out those 5 x's. How many y's are on top? 2. In the denominator, I have a 2. And how many x's do I put in the denominator? 2, because x squared, and there's 1 y. So now all we're going to do is we're going to start canceling things out. First off, looking at my big numbers, that's the first thing in my problem. Can I actually divide 5 and 2 without getting a decimal? No. If you can reduce your fraction, that would be your first step, but in this case we can't. So we're just going to leave it. When we go to write our simplified form on the other side, we're going to leave it as 5 over 2. How many x's are in the denominator? So how many x's do I get to cancel out? 2 of them. All right, how many y's do I get to cancel? 1 y from top and bottom. So now I count up what's left. How many x's do I have left on the top? 3 x's. So on the top, I'm going to write x to the third power. If they were left in the denominator, I would have written that in the denominator. How many y's do I have left on top? Just 1. Okay? So that would be my simplified form. 5x to the third times y, all divided by 2. Okay. Now let's look and see what happens if we have negative exponents. So for problem number 1, we have x to the 5th over x to the negative 2 power. I'm going to list or expand this out. In the top, I'm going to list my 5 x's. If I list this out in the denominator, I have x to the negative 2. Is there any way that you can think of to actually show that they're negative as you list them in the denominator? A little negative in front. A negative in front would actually change it, since that becomes now the coefficient and not really your list, right? Exponents just tell you how many are in a list. Can I show a negative list? No. So what we do, in order to show that it was negative, you actually take these and you list them on the top. Your negative exponents will flip their position. Oops, and I moved that where you can't see. Oh, I didn't mean to write it there, sorry. Yeah. Meant to write it by the negative exponents. That's a P. Flip. Flip with an F. F. Okay. Okay, whatever. So I'm going to list these in the top, my 2 extras. So now if I want to go through and I want to simplify it, for problem number 1, pardon me as I fold my paper, how many x's do I have listed? 7. Are they on the top or the bottom of my fraction? Okay, so I'm going to write x to the 7th on the top. If I needed something in the denominator to hold this fraction together, what number can I use in the denominator? A 1. Do I have to keep a 1 in the denominator? Doesn't mean anything. No.
No, you don't.
So your final answer here would just be x to the 7th.
So what about those negatives?
They just flip. If they come to the top, then you can make a list.
So they just turn positive?
Yep, so they turn positive. They flip and become positive. So let's look at number 2. Number 2 on here. Number 2, you have x to the negative 2. Again, we can't show a negative list.
So you put on top.
Well, we have to create a fraction as it is at the moment. So how do I turn this into a fraction? I can put it over what?
X over
Over 1. So now, do I have a way to flip it?
yes.
Yes. I can take this fraction, and I can list these x's where?
Oh yeah, give me
Not on top. They're already on top. On the bottom now. So I would list these x's out on the bottom, and you list 2 of them. This time, in order to hold my fraction, what do I need to have on the top? A 1. So if I wanted to write my simplified form, I would have a 1 on the top, and what's in the denominator? How many x's? X squared. All right. One last problem. All right, so the last thing, what happens if you have an exponent that's 0? Your exponents, again, tell you how many times something is listed out. If I look at problem number 1, I have 12x, all raised to the 0 power. How many times am I able to list out 12x? 0 times. That's right. I cannot list it. It's raised to the 0 power. There are none of these. So what happens is, this all, since it's raised to the 0 power, becomes a 1, because we need a placeholder. Yeah, I did.
Is that the answer?
No, the answer was 1 over x squared. So for problem number 1, 0 exponent, the answer would just be 1.
So anything that has an exponent of 0, that's
That's right. So looking at problem number 4. Look at problem number 4. We have 3xy raised to the 0 power divided by 4. So if I write my fraction out, how many times can I list 3xy? None. So what am I going to put? A 1. What do I have in the denominator? A 4. So my simplified form would be 1 over 4.
So if you got a 0 as the exponent of the outside, it's just 1.
That's correct. Okay? So now we're going to go back and you guys are going to fill in all this information.